Hello, everyone. Thanks for joining today's Masterclass Series Part 4, Model Monitoring and Retirement. We are extremely pleased to have as our presenter today, Model Ops Chief Technology Officer, Jim Olson. With that, I'd now like to hand it over to Jim.
Excellent, thank you. Today, this is the fourth in a series of the Masterclass, so it's the fourth and final series today. So, just to recap where we're at, I encourage you to, if you haven't seen any of the previous ones, those are available online, and I encourage you to watch those as well, that they all cover unique aspects of basically managing risk overall with your models. That's the goal with each one of these classes today. Today, the previous three classes, what we've done is very much about how do we actually move the model out into production, but we haven't crossed, what happens after that. So today in the final class, we'll actually be covering, okay, now that the models are in production, what do we need to do to ensure they're performing correctly, that they're healthy, and all models have a shelf life, so how do we eventually retire them, and how do we look across the models as a whole? Again, today's class will be largely hands-on demonstration of our capabilities in this space, but we're going to do a few slides up front just to kind of set the stage of what we'll be doing today. So, to remind you, what we're really following is around this overall SR 11.7 guidelines and a process that basically mirrors what's required there, and that they've generally believed, if you follow these items, you're going to be largely in compliance from a government perspective, but also you're protecting your own business as well, because they're very, very extensive guidelines that tell you kind of all the different steps that you can take throughout that. So, we've done basically kind of the define and the develop and all of that things. And now we've actually in the last class got it out into production through a pre-production environment and all of those steps. And today we're actually going to go into now that it's out there, how do we ensure that model continues to be healthy? So, we refer to that generically as model monitoring, where we're basically going to see different information about the model. This is fairly standard in a lot of different solutions where you see, drift monitoring, concept drift monitoring, bias analysis, all these kind of things as new data about the model arrives, because, we really want to catch these situations. Now, what's unique about our solution we'll be demonstrating today is not only do we detect these situations, but then we drive a remediation process. So for today's demonstration, we're going to show you how you can actually add a monitor to a version or a snapshot of a model. But not only that, those monitors are configurable and we have them out of the box, and you can develop your own and we can treat the same. But you'll see how we actually are going to drive a remediation process where often when we do detect an anomaly in a model, we must create a exception report. And basically, we're going to actually auto-populate an exception report with the information about the model test that was run, and show you how you can make your own templates for that. And then actually created a JIRA ticket that somebody must actually address and resolve that has that exception report within it as well. So we're going to walk through that and track it through the review. And in reality, this is an abbreviated process. We could actually make sure that the replacement model was put in place on that kind of things. I mean, why do we do this? Well, all monitors all models that are developed out there are based on a set of assumptions about the original data they were developed on. If you call back to March of 2020, a lot of our customers suddenly had a lot of models failing, especially in the financial space, especially when you look at things like fraud detection or things like that was going on. Because, when all of a sudden all the businesses closed down and everything went online, every model that was developed did not have that kind of insight in the past. So, a lot of people were scrambling to determine which models were affected by this and things like that. These kind of monitoring solutions really do give you that ability to say, hey, yeah, the very nature of the data itself that's now coming in, it differs greatly from the original data that we developed this model with. Now, AI models are particularly sensitive to this because of the training data, but even an untrained model, let's say it's just an if-then-else statement, if you develop that based on some premises about the expectation of how the data looks and what the data is, it can potentially say, some of those statements and decisions you made may have actually changed. So they're no longer valid. So even though the data itself was not put into the model, the rationale behind that data may have. So, we're going to show examples of things like concept drift and data drift and things like that in detections, but more importantly, actually driving a remediation process after we do detect there's an issue to make sure somebody does go look at this. That would have saved a lot of time back in March of 2020 when all these models changed. Rather than chasing them down, they would have gotten direct reports of these are the ones that are likely affected. So these are real world situations that can happen to you out there as we do this. And additionally, all models likely have a shelf life. And you want to actually be able to say, hey, there are models that are out in production that are likely going to expire soon, and make sure somebody's looking at getting a replacement there, revalidating the model, or whatever needs to be done there. So part of a model risk strategy is definitely to identify when models in your organization are reaching that shelf life, and we need to actually make sure they get addressed, as well as just understanding the workload across the business. How many of these models are out there in my business unit, for example, that are getting close to needing to be done, and do I have the resources to address these and fix these and things like that? So also understanding holistically across all of your models how what's deployed out there is not only performing, but will likely need to receive some attention going forward. And we can show you how we can actually develop these kinds of dashboards, et cetera, that provide you that information. But again, we can actually get ahead of it, so to speak, and say, I mean, obviously we'd want more than 15 days for a model expiration notice. It takes longer to develop that, but for purposes of a demo, basically we can say, hey, one of your models is getting close to expiration. Here, you need to go look at it. And again, making sure that your model risk management solution drives this process, not only just sends out an email or alert into a bit bucket somewhere that's likely to get missed, but actually track that something is really being done about this, because otherwise these things can really stack up on you and just become a crushing workload. You want to make sure that the model ops solution you use, it can actually help you resolve that situation on that. And finally, as I started to mention last time, we really do want to also be looking across the entire business how the models are actually performing out there. So we'll show you how we have out of the box kind of Tableau dashboards you can use, so you can share these reports and brand them as your reports for your corporate identity, et cetera, as well as how we can look at individual business units and stuff using that same code, and how it just seamlessly integrates with our system to develop these and pulls the information right out of our system live into those dashboards, so you really can get that holistic view of what is going on with your models, how many things have issues, how many things are performing well, and there's even return on investment and different kinds of calculations that can be done there as well on that. So, really can provide you that holistic information. So as I promised, rather than spending a whole bunch of time in slides, that's kind of the background of what we're going to go through today. So now we'll switch into actually a live demonstration of that. And for that portion, I'm actually going to switch off the video just to give you a little more space on the screens, because there's going to be a lot of stuff we're actually going to look at here. So once again, we're going to go into Model Ops Center, and we're actually going to start kind of where we left off. We actually got a model out into production, and now we want to actually set it up so that it will be monitored on that kind of things. So, when we talk about monitoring, I'm going to give you an idea of some of the out-of-the-box models that we actually have. So we treat our monitors just like other models within our system. We manage those monitors. They are Python code, C code, Java code, whatever, that actually perform the calculations on the data associated with the model. So they're not actually directly tied to execution of the model. You don't have to modify your model code at all. It can monitor any kind of model. It doesn't matter what language is written in or where even it runs. As long as we can have access to the data, our monitors are actually models themselves that get applied to the input and output data. And we'll show you how we actually do that and the requirements vary as to which the data. This is one of the reasons why, if you remember from the very beginning of the masterclass, where we actually verified that they provide us stuff like baseline data, training data, et cetera, because this is the information we need in order to do those kinds of comparisons. So for instance, for things like drift, et cetera, we want to actually, we need access to that original information on how the model was developed, and we'll show an example of that here in a minute. So you can see where we have a large variety of models already in there based out of the box. And if we go and look at any one of these models, they look like just any other model within our system, and they have versions, and you can snapshot them and you can share them across your organization so that you can have these things standardized, and you don't have to have every data scientist trying to replicate these. And more importantly, if you're doing it on 6 different platforms, it would become onerous to put it within the actual code itself. So by instead having these written that run on our runtime, you can actually don't have to do any modification to the model at all. So you can see where they actually have these. This one is implemented in Python, and we actually can track the information about what how it actually works and things like that. So we have all of that information there. This becomes important because what we're going to show you is how we can actually apply one of these to an existing model and have it automatically run on a regular schedule and generating those JIRA tickets if things fall out of line. So we're going to start with looking at kind of some of all the possible results you can get for these. So I have one that basically I've gone ahead and actually run every single monitor on to give you an idea of the breadth of what we can actually deliver within our system. So, we can have the very standard kind of metrics like the F1, the stability index, record counts, that kind of things, p-values, et cetera, on there for kind of a summary metrics. But then we can have things like we have a Shapley monitor where we can actually use SHAP and Lime for interpretability of what the highest influencers on the prediction were. So we can do those kinds of things. We can also run different kinds of bias results where we actually can look at things for like against a comparative group. So for instance, this one's run against a protected class race. So we can actually do that and look at the comparisons there of how it's performing. Or if we just want to look at all items across the group for a protected class, we can do that as well, where we can have that kind of information and do that. And you can see for variety of different things there. We also have basic performance metrics of precision, recall, accuracy, et cetera, very standard ones. We'll be using an accuracy score today because it's very straightforward and easy to things to show you how we can actually set limits within the model for these different items. We also have things like a variety of different data drift methodologies. So we can actually detect if the original training data and newly arrived data are actually differing too much, and might be something we want to look at on that, as well as simple things like just numerical comparisons around the nature of the data from a simple statistical standpoint on that, as well as the categorical comparisons, as well as concept drift. If we're looking at different things where, the predictions that the model is producing now seem very, very different than the original sample data that we actually did those predictions on, and being able to get that. So even if we don't have labeled data, we can look and say, hey, something's off here because we don't have that kind of information, as well as standard things like stability analysis as well, where we can look at all the different items that are available there and look at them by feature as to this overall stability that's available there, as well. Simple things like just even volumetrics or those or summaries as well. So you can see we have quite a quite extensive collection out of the box. But the cool thing we've done is because they are themselves models, you can actually register your own. You can develop your own in any technology you want, and we can actually execute them across that data and action on them and provide all those other things. So as new technologies come online, we are actually future-proofed against those technologies. So we have those ability. So how do we actually put one onto a model? Well, we're going to actually go to our German credit risk model that we actually have, and we have a snapshot that we've actually put out there. And you'll see that there's basically the idea of monitors that we can actually add to this. So we're going to go ahead and actually add a monitor to this, and then we're going to manually run it, but we'll show you how you can schedule it as well. We're going to, in the interest of time, we're going to manually fire it off. So we go to actually add one. As you see, here's our list of all of our different monitors that we had that we can choose from. And if we pick any particular monitor on there, you can see how we can actually get information about the monitor itself and what's there. So if we were to actually go on, we can actually receive information about what it outputs, what kind of data it expects, and et cetera, so that you can provide that information on that. We're actually going to go back though and select a different monitor for the purpose of this demonstration. So we're going to grab a simple monitor that will run quickly that I've put on here and that I've set up for this demonstration. We're actually going to go ahead and actually bring that in, and you'll see it tells us that the sample data is required for this specific one because we're doing some fairly simple analysis on this one on that. So we're just going to go ahead and we can actually, it'll show us all of those references we made sure were there earlier in the process, and we're just going to go ahead and actually grab that sample reference. So this is a reference to data that's actually in there as well. So we're going to grab that, and then we're going to go on to actually add a threshold. Now, one of the unique solutions we provide is we recognize that every model is going to have its own unique thresholds for what are acceptable values. And that's probably going to be a combination of things, not just a simple, accuracy is greater than this. It can be accuracy is greater than this, false positives are less than this, and blah, blah, blah. So to do that, what we've actually done is we've made it so you can actually add in a DMN file. The DMN file is basically a description. Now, in the interest of time, I'm going to import one that I've already got set up here. That's pretty simple, where we can specify the different metric that we actually want, and we can do ands or ors or any kind of combination of these and set thresholds. And these are actually full field expressions, so you can go into quite sophisticated things. I've made them simple for this demo. We're going to say if the accuracy is less than 0.8, we're going to fail the item, and actually we can provide a textual reason back to the user. So we can edit this all right in here and actually do that. And it gets stored as a DMN file that then gets associated with this monitor. So give it just a name. And when we do that now, we're actually going to have that threshold.dmn that's associated with the file. And this is where we could actually choose to add a regularly fired schedule, daily, hourly, weekly, et cetera. And, it's a standard cron expression type process where we could run this on a regular basis. On that, we're going to leave one off for now because we're going to manually fire this in the interest of time. And then we're actually going to have applied this particular monitor is now applied to that version of the snapshot. One thing I didn't point out earlier is also associated with this snapshot, we have an exception report. We're actually going to generate an exception report. Now, that's just a generic Word document where we've actually taken exception report, where we've actually taken a Word document, and you can see where we've added in tags to the Word document that will automatically get populated by ModelOp when it actually fires, and we'll show that. So we can actually pre-fill out the exception report for you with test results and all that. And that's associated on a model by model basis. So you can actually have unique exception reports for that model if you want to as well. So now that we actually have that all set up, I'm just going to switch over to that model lifecycle we were looking at earlier, where we can see the things. Now I'm just going to quickly manually fire this off. So we're going to go ahead and actually run a simple post to it to fire that signal. And you'll see we actually fired it. So now it's actually started. This would typically be started by a cron job. We're actually running that request, and we can see it actually went and created a failure because it failed that DMN for some reason. So we need to go find out why. Well, as I said, the nice thing is we're going to track that all through JIRA. So we can see that we failed that associated model test run, and you can see the reason now, that DMN table. The accuracy does not meet the minimum threshold required. And rather than going and actually chasing down that value or whatever, we have our exception report already filled out that they can look at. We'll go ahead and take a look at that, where we can see the actual the actual exception report. It's filled in the name, the model description, the ID of that model, the location in Git where that model actually is, and the exact commit ID that it's running from, as well as the failed test results. So yeah, you can see the accuracy is only 0.66, so definitely failed that. And we've also provided the other items. So you can see we have a robust exception report. We can now log and track for any MRM compliance issues on that our system is generated for you, and you don't have to go and do all this, as well as that gives me the information I need to actually go and chase down and remedy this problem on that. So we have that kind of ability to do that. So, that's pretty powerful. And again, a big differentiator off of a lot of systems that just generate a simple exception of monitoring. We will fill out the document, make sure somebody looks at it, and they're going to have to go and actually, complete the task and say they've done it. And we can track that they did this back into the model. So when we go look at, it'd help if I don't close the entire window there. Let me bring that back up. If we go back to Model Op Center, if we go look at that model now from the development standpoint and look at that version, you'll see we actually have received that notification is now always associated with it. We can always get right back to that ticket of how it was resolved or not and that kind of thing. So we have that information linking it all up. This becomes important because one of the ideas is we want to start to look at these models, not only monitor them through this strict statistical standpoint, but we want to look at them across the entire organization. So we want to actually be able to see what is out there. Like, how many models do I have that has a PSI issue or a MAPE issue or these kinds of things? So, we have this kind of information actually available to us. Or, for instance, we can actually look at something like a non-compliant dashboard where we're actually looking at the models that are which different kind of risks, how many of these, what kind of models are they actually doing, and what's the issue? So like here, we were talking about expiration and expiration detection. We could generate those automated JIRA tickets, but it's nice to know that, hey, we have a bunch of expired models of these different types out here that we can actually look at by the actual model name and business unit. So again, we can do some load planning on that kind of things, as well as just looking at a per business unit, what is going on within my business unit on that. What kind of models do we currently have? How many of them are in production? How many non-compliant models do we currently have? Because let's get real, when you first institute this stuff, it's going to take a while to get into compliance. So we need this kind of information to actually interact. And the neat thing is we've done this both in Tableau and Power BI in such a way that it becomes easy to build your own dashboards. We have these ones out of the box you can currently use, but we basically also make it really easy to bring these in. Because what we've done is we've actually, so for in the instance, the case of Tableau is we've implemented a web data connector where it'll actually talk directly into our system and allow you to bring the data directly from our system right into the Tableau dashboard. So for instance, if we want to look at deployable models, those model snapshots, we can actually instantly grab that information into the system where it'll actually just pull right down to a table. Or maybe we actually want to look at the actual test results that are compared to that. So, we can join those two together. We get the idea of that deployable model and search for it in here. We can get that deployable model ID right in here and tie those together so we can actually make a related table on this and update now and actually get like all the test results for all of the, if I close that properly, we can actually get all the different test results for all the different model versions that are actually out there, and then build those into tables so you can see where we get, for instance, the failure reasons that we saw earlier of the different things. So you can see how you can pull these in and build all your dashboards and do this all right from within Tableau, but it's backed by the live data that's within our system. And we believe that really helps in kind of pulling that information together so you can make these kinds of dashboards, because of course we provide you these, but you're going to have unique business cases that really match what you need to do out there on that kind of things. Okay, with that, that's kind of the overall presentation I want to give you today on how we monitor models within the business, and then how we look at all of that data and do that, and how we action on them, because that's a key thing. Is any monitoring solution you should use should provide a remediation path, otherwise they just get lost. And that's one of the unique things we built into Model Ops Center. So with that, if there's any questions within chat, I can take those. I did receive a direct message of another question, so I'll go ahead and take that one now. There was a further clarification around what you actually have to do to your model to actually make it monitorable. I do want to point out really what we do different. You'll see a lot of other solutions where you actually have to import their library into your model and then execute that and things. Because our models are actually designed to look at the data itself. So for instance, if we look at the MRM German credit risk model and look at the assets, if you remember, we actually made sure that they provided us things like the baseline data and the training data and things like that. Our monitoring models don't actually have to execute the model, and in fact, don't execute the model. So we can even do things based on just a simple Excel spreadsheet and monitor them to test them for performance. As long as we have reference to these JSON, they can be any format. It can be a SQL statement, it can be a JSON, it can be an S3 bucket, Snowflake call, all different kinds of things. As long as we have access to that, our monitors directly read that information and then do the statistical comparison within our model's code. So it really keeps it clean in that you can switch monitors, you can add monitors, you can remove them, and you're not affecting the model code. And that's key to actually providing kind of the overall, how you refer to it, the overall integrity of the model. Because if people start changing code in your model and you've already verified it, you can no longer say that it's the same code. We don't know what actual changes occur. So we took that approach because that approach also lets you do the same thing by basically being able to go out there, look at the data yourself and come up with whatever statistics you want. We've worked with companies that have their own internal proprietary statistics, like a score factor, how the company's doing, or things that are very, very specific to the business. You can add those as a Python, a C, whatever kind of model, anything that would execute on our platform, and you can register it and add it to a deployable model snapshot, just like any of the other ones we actually have there, and actually execute it and have a decision table and actually action on it and et cetera, just the same. You don't need to write any extra code to do that. Our framework will absorb it and execute it. And again, that's one of the things we really think is a big differentiator within our product on that kind of things. Looking to see, I'm not seeing any other questions, and we are right at 12:30. So I really do want to thank you for actually joining today and in this final class in the series. And I look forward to doing this again with you. And again, I encourage you, if you missed any of the previous sessions, please feel free to watch those online. It's a great comprehensive look at model risk management using Model Ops Center and Model Ops to achieve quality and risk reduction within your model development process. So again, thank you very much for joining.